So in the last video, we looked at the correlations. So in the diabetes database, we had looked at various variables such as S1 to S6. So just a quick recap. We looked at these variables S1, S2, S3, S4, S5, and S6 respectively, and explored the correlation between them. So a simple way would be just to create a data frame which has all of these variables bundled together, and then we can just use a core function to get the correlation, which is a quantized representation of the relationship. So the values range from -1 to 1 depending on the strength of the relation, whether it's positively correlated or negative correlated. And a good way to visualize that, rather than using the conventional pairs command, is to use a heat map, which is essentially color coding the nature of relationship. So essentially what we're doing is we're providing a color map palette which ranges from red, yellow, and green, and then we specify the resolution of colors as to know how crisp or sharp the contrast needs to be, and the crispness of the contrast would be associated with the distance, and the distance itself is associated with the correlation. So that's how the thinking behind color map is. And once we plot this, we can see that diagonally, since it's a matrix, diagonally we know that S5 to S5, S4 to S4 correlation would be 1. And the way we have calculated distance, in this case, distance would be 0 because we have done a 1 minus. And hence we get a uniform color of green. But if you look at S3, comparison of S3 versus the rest of the variables, you can see that this is bright red. That means, varying shades of red. So we know that S3 stands out in terms of its a conflict or negative correlation, whichever we want to look at it, compared to the rest of the variables. So we know that S3 has negative correlations with S2, S3, S6, and so on. So that's how we can separate one or more variables from the rest.